Okay, I think we are live. So we will start our webinar and let's hope we can get everybody in here fairly quickly. Jordan has a lot of information to share with you today, and our presenter is Jordan Whiteley. And he is with Mercurio's Heating and Cooling. And he will be taking us through the heat pump systems webinar. A couple housekeeping things first. If you have not done this with us before, you should have a bar at the bottom of your screen that shows Q&A, polls, and chat. You can ask questions in the Q&A or the chat. You will be silenced through the presentation. If you ask the questions in chat, they come up where everybody can see them as they're going through, and they can see the answers instead of having them answered to you personally, which is the way it tends to show up. The polls, we will start with one while we're getting folks in, and that will be asking you how you heard about us. And then I will be introducing Jordan. Before I get into that, we will include in the chat, I will include links on how to reach me and how to reach Jordan, how to reach Tacoma Power, and how to sign up for other webinars, to see the recorded webinars at both the House website and on the city's YouTube channel. And I would also mention that the next one up is October 23rd, pruning landscape trees, and followed by pruning fruit trees October 30th, and then an introduction to mason bees on November 6th, so that when we get into February, March, when it's time to be starting, get your mason bees and your fruit trees ready to go. So with that, let me bring up the first poll. And this is, how did you hear about the EnviroHouse workshop? And if you can answer that, those of you that have logged in so far, you should have gotten a reminder yesterday. Well, if you're not on here, you're not going to hear me say you should have gotten a reminder yesterday with the link. So not very many have joined us yet. So they may be planning to come back later and watch it. Okay, half of you have answered. No. Yeah, half of you have answered. So we will just go ahead, and in that, most of you got it from the EnviroHouse, the EnviroNews email, which is what I post on. Several of you got it from the Facebook events, and a couple of you got it from your friends, family members, or workplace. So I'm going to end the poll. And those poll results will not be in the webinar. This, for some reason, doesn't show up, I guess, because it's a shared screen. So there you can see what we've got. And I'm going to stop, whoops, stop sharing. And move this out of the way, because if I end it, I can't open it again. And Jordan, do you want to give a little background about yourself? Jordan has done a lot with heating and cooling, and knows a lot about this subject, and he's got a really cool background there showing Mercurio's truck and a heat pump behind his head and some other things there. Okay, so Jordan Whiteley will be chatting with you about this, and I'm going to take my screen off and mute myself, and then if we do get Q&A, I will pop up Jordan in case we need to do an answer. Okay.
Sounds good. Yeah, if there's questions along the way, you can interrupt and we can answer them. If it's a smaller group, that's fine with me. All right. So I'm taking over, Janda? Yep, you muted yourself, so that's yes. Good morning, everyone. My name is Jordan Whiteley. I am a Tacoma born and raised. I worked at Tacoma Power for almost 8 years doing energy conservation and helping customers with their energy bills, aka the high bill complaints, or just understanding electricity usage and how it reflects to how we use electricity and other fuels in the home. So I'm very aware that this is going to be me kind of talking to my screen for a little while here. So we'll do our best. Any questions? Feel free to hit them with Jan or shoot them to Janda, and then we can maybe address them and have a little conversation. So here we go. Heat pump systems. I want to get this to go for me. Okay. So heat pump equipment is popping up everywhere. So basically, heat pumps are in our everyday lives right now. Everyone should have one. A refrigerator is a heat pump. Your car air conditioning is a heat pump. So pumping heat around, moving heat, moving energy, essentially. So this is the side of a building, and as you can see, there's an outdoor ductless compressor, and then there's a heat pump. There's a type of heat pump water heater. Different areas around the world adopt heat pump technology faster than others, and they also adopt different types of heat pump technology. So we'll be touching on a lot of that. So kind of a rough agenda for today, or what we hope you will leave with a little bit of knowledge and maybe a little bit of info and things like that. So how they work, why they're efficient, basically why utilities want to have programs to have customers adopt these technologies. And then maybe some of the stigma or, like oh, they're really noisy, or they don't heat below 50 degrees, things like that. We can touch on a lot of that. Their reliability, which is going to reflect reliability is, really close to who installs it, how it's installed, and how it's operated and maintained. And then some of the advantages and disadvantages of every technology. It's a different type of heating system and cooling system, and you just got to be aware of how that reacts with your home and your expectations. So some of the stuff we'll touch on. I see that we have a chat question. Or no, Janda launched the info. Thanks, Janda. All right, cool. So we're moving on here. And if I can get this bad boy up. So before we begin, let's learn about what heat is, or how we heat our home. So Janda, would you like to, there we go, on the spot. So basically, what kind of heating system do you have where you live? Sometimes you hear about the box in the garage, or it comes out of the wall. I've had some customers who know the SEER, the date, the BTU rating, the KW rating. So everyone has kind of a different interest in their home's heating. So we're about 75%. We could probably end it now that we're there.
Okay, so we will.
404, there we go.
Okay, there we go. All right. So some of you already have heat pumps, which means you are familiar with some of this. I just had to get a new gas furnace because the way my really old house is laid out, I couldn't make a heat pump work, and I've been sad ever since. So pay attention.
That's so here we go with the results. We got one gas furnace customer out there, but the other one, the other three, our other attendees have traditional heat pumps. So if you have traditional heat pumps, we can that's good to know. One gas customer, you can learn about maybe some of the advantages and some disadvantages of going to a heat pump with your gas system. And then traditional heat pump folks, maybe this can be beneficial to learn how to use your system better, or maybe give rhyme and reason to some of the things, some of the benefits and drawbacks that happen with your system. So we'll kind of touch on all of it, hopefully. So let's talk about heat. So these are electric heating systems. So as you can see on the left side, we have an electric furnace. In the industry, sometimes we'll call that an air handler. But an electric furnace is a blower motor, which is that big circle on the bottom. And then right on top of that is a bunch of elements they're pretty much identical to the toaster on your right. So if you're going to do a bagel and cream cheese in the morning and you have an electric furnace and it's a cool fall day, you're making heat the exact same way that you're toasting your bagel and you're heating your house. Below that, that's a baseboard heater, same technology, making heat with electricity. Baseboard is considered zonal. Furnaces and air handlers are considered central or kind of unitary. Baseboards are usually below windows, and if they're not below windows, sometimes it could be in an addition or a remodel or something like that. But baseboards are usually below windows, as are registers from a central system. So what we're looking at here is traditional electric heating. You're making heat from electricity by heating up elements. So I got a question here real quick, Jan. I'll just read it out.
Do you want to hold on that one, or do you want to answer it now?
No, I can answer it.
Okay.
No. So a certain customer had a 13-year-old heat pump, and they're interested in learning about their lifespan and kind of replacement options. So that's good. Well, we could touch on a lot of that. Or I think that this will be beneficial for that question. I'll do my best to make it beneficial, right? So these images here, making heat from electricity, aka traditional electric heating systems, not a toaster, but as an example. So when we go to the next slide, these are again, we're making heat. We're just not making heat with electricity in these examples. We're making heat from materials, aka like we got an oil tank. So that's old oil furnaces, which there's a lot of oil furnaces in Tacoma, or excuse me, homes that were built with oil or had existing oil. On the right side over here, we have a gas furnace. This could look like your old 80%er gas furnace. So, and then lastly, we have a fireplace, wood. Burning wood heats up and heats the metal, and the metal radiates the heat in the house. There's usually stone behind it. Stone's a really good, stone's a good battery for holding energy or reflecting energy, not just having it hit the wall. So with these systems, they're similar to the electric side in that you're making heat from something, you're burning something, or you're having elements release heat. With these systems, you're never going to be 100% efficient because you always have to have exhaust leave the system. So, the classic silhouette of a cabin with the smoke out of it, that's heat loss. Your vent from your gas furnace, that's heat loss. You're never going to be to 100% because you don't want carbon monoxide in the house, essentially. So again, these are the systems that are usually out there that are making heat from something. See, I'm harping on that repetition, making heat. So when you're making heat, you have a certain efficiency, but now if you shift to a heat pump, you're moving heat. So this is just kind of the first kind of hit of a traditional heat pump system, aka like a unitary system or central system. That electric furnace, you have an air handler, you have a heat pump, and then you have ductwork, which is supplying the home. Ductwork is probably the most important thing for a home with any type of heat, but specifically with heat pumps or air conditioners. And then central systems always have a thermostat. So there's always one spot in a home where it's sensing temperature, where the home has multiple rooms with multiple doors and sometimes varying levels of efficiency. So what is, let's see here. There we go. So heat is measured in BTUs. So BTUs are going to be thrown around. BTUs are a British thermal unit. So this is someone got really had some fun with the animation on this one. Didn't see this one coming, but we'll work through it. This is basically the amount of energy used to heat. I'm not going to read the slides to you, but to increase 1 pound of water 1 degree. So lastly, but it's a match strike. So BTUs are transition from electricity from kilowatts, kW. So standard sizing for furnaces is kW. I have a 15 kW furnace, a 10 kW furnace, and then there's a factor to get that kW to BTUs. Natural gas, oil, propane, things like that, they have how many therms go in, what's the efficiency and the size of the heat exchanger and the burner and the valve and whatnot, and then you get how many BTUs come out of it. So BTUs are normally in the tonnage, which we'll touch on, but you're going to see that systems have a lot of BTUs. You can't heat a house with 1 or 2 matches unless you start a fire. So 12,000 BTUs is considered a ton. So I'm going to start getting these all on the page here. Whoops, sorry. So 12,000 BTUs is a ton. When we refer to HVAC systems, specifically heat pumps, air conditioners, and ductless heat pumps, you're going to hear folks talking a lot about tons, tonnages, half ton. With certain systems, you can talk about how many tons a given space of a home needs. And then I know who created this slide, and a guy who teaches at Bates said it comes from taking 32 degrees of ice to 32 degrees of water. So I tell folks a ton of ice has 1 ton of cooling capacity in it. But just keeping in mind, a ton to us sounds like weight. A ton to heating and cooling is 12,000 BTUs, specifically the movement of 12,000 BTUs, or how many BTUs we can give a home. So when it comes to refrigeration, you're moving 1 ton, 12,000 BTUs, as opposed to making 12,000 BTUs. Back to the gas, oil, electric furnace stuff. There's a lot of examples in here, a lot of numbers. You guys will be able to read this. I think Jana will share the slides and whatnot. But 12,000 BTUs is a lot of heating and cooling, and it's important to know how that's moving. So when you're adding 12,000 BTUs to a home, you have to get that energy from somewhere. And with refrigeration, the refrigeration process is it's removing the energy from the outside air, and outside air holds temperature, energy is heat, and it's absorbing that energy. It's compressing that energy in a vacuum. And when you compress a gas that has energy, it gets hotter. And then if you send that inside the home and have a means of air going over that heat exchanger, you can get that energy in the home, AKA you can move energy from the outside air into your house and gain efficiency. And that's the kind of the refrigeration process. So I'm going to kind of click through these a little bit, get these on the page. I'm not going to read the slides to you guys, but we've kind of touched on this, and I'm going to keep touching on it because it has a lot to do with how heat pumps work in a home, and some of your expectations, and kind of where heat pumps are today from where they were 10 years ago and things like that. So again, we're not making heat, we're not creating heat, we're moving heat with refrigeration. I'll have some images to back this up, so it's not just text at you guys, but there's heat in everything. I think you have heat until you have absolute zero. And so sometimes folks think, well, if it's 30 degrees outside and I have a heat pump, there's no heat in the air because it's cold. It's cold to us, but there's still significant amounts of heat in 30-degree air, even in 0-degree air. A lot of the heat pumps now can remove energy from the outdoor air with the refrigeration process down to -5 degrees. So if you can get heat out of air at -5, you can get a lot of heat out of the air at 30. There's some things that come into play there, though, because if you're trying to heat your home and it's 30 degrees out, and your heat pump can move that energy into your house with different types of applications, but your house is also losing energy at a faster rate than it would be at, say, 45 degrees outside. So those are some of the kind of stuff to think on, especially with central homes, central duct work. The duct that is kind of farthest from your gas burn or your furnace or your electric air handler sometimes can be last in line to get that heat. Ductwork that's not insulated or sealed could be leaking a little bit, and it might be magnified by colder temperatures. So if our bedroom isn't insulated, it can get some heat when it's 45 out, but when it's 35 and 30, that room is losing heat at a more rapid rate, and you want to get more heat in there. So there's all these kind of balancing acts that are just good to stay mindful of. And it's really good to communicate these to your contractor who's out there kind of looking at your home, because you guys live in it and you guys have the most or the best understanding of how it works and some of the shortcomings of the home that we can maybe look at. So we're off text, we're to visual. I'm a visual learner. So operation. So on the left side, how does a heat pump cool? So I tell folks, if it's 85, 90 degrees outside and you want your house 72 to 74 degrees, which is kind of standard for cooling around here, the system is removing heat from the indoor air and it's evacuating that heat outside via refrigeration. So what does that feel like to us? We want to know how it feels, right? How does heat cooling feel? Warm air carries moisture. Warm air in a home goes through your ductwork or over a heat exchanger, depending on the system, and it hits a surface that is removing the energy from the air. And we're looking at the left side here. If the system is removing energy from the air is going to get colder because energy is heat. And if that coil is colder than if that coil is at dew point, it's going to collect moisture. It's going to condensate, and so that's why ACs always have condensation in a drip line that we mitigate with PVC or condensation pumps and things like that. But kind of the magic, I had a friend's dad that always said, magic juice, magic juice. Well, the way the refrigerant works is it's not magic, but it's removing the energy. The refrigerant is absorbing that energy and it's going outside and it's going to release that energy to the outdoor air. So essentially, if it's 85, 90 degrees outside and you have your AC system or your heat pump system running on cool mode, and you go take your hand and you're outside, it's 85, 90, and then you put your hand over your outdoor compressor, which would kind of be right there if I was in the field looking like a giant, I'd feel hotter air. The air is going to be significantly hotter because that heat pump system is removing energy from the house. So flip the script. Let's say it's a day like today. Maybe it's 50 degrees out, 45 degrees out, and you want your house at 70, 72. On the right side of it, the outdoor unit is going to move it's going to bring a lot of volume of air over the heat exchanger so we can get, bang for the buck, right? It's going to have a lot of surface area with the outdoor air. It's going to remove the energy from the outdoor air, compress it, get it hot, and then as you see the lukewarm air in your house going over a hot heat exchanger, the air in the house removes the energy from the coil, the air gets warmer, the system moves it around the house until the thermostat's happy at, say, 72 degrees. But outside, if it's a day like today, your system's running, it's 45 degrees, maybe 50, and you put your hand over the top of the unit, the air is going to be colder than the surrounding air because you've removed energy from the air. So that's me yapping about that. So heat pump for space heating. So we kind of talked a little bit about a little bit about the different applications and whatnot. So heat pumps provide heating and cooling. The refrigerant can do two ways. It's a two-way street for refrigerant with a reversing valve. So air conditioners only have the system go one way. So air conditioners are a type of heat pump. It's pumping heat from the inside of the house out, but it's only a one-way street. Heat pumps can do both. That's good to know. And then there's significant heating costs savings to a heat pump because when you're moving energy with electricity and the low residential rates of Tacoma Power, there's the plug, you can get you can move a lot of heat for the amount of electricity you're paying for to operate your system. And there's different levels of systems and how they operate. But the gist is there's all types of metrics for measuring the efficiency of a system in regards to how much energy it uses to move heat or make heat. But heat pumps always exceed that. So you know what? I think there was a poll question on this, and I may have just given everyone the answer, Janda. But let's hit it with them anyways and see what they have to say. Can we do that? How efficient do we think a heat pump is? Maybe I lost Janda. Oh, there she is.
And my volume up. I just lost the poll question. I gotta find it.
Well, we can probably just hover over it. I'll give folks the answer to keep moving.
Okay.
Heat pumps are more efficient at heating than gas furnaces and electric furnaces. There's the answer to the test before you got it. But so that's the cost savings, right? Efficiency equals cost savings because it's all about the price of energy. They're more efficient than, they're getting even more efficient than heat pumps were, say, 10, 15, 20 years ago. So for the customer that has a 13-year-old system, it'd be good to know what type of efficiency that system is, how that system has been working with your home. Because some of the other things that have changed over time with HVAC is sizing and kind of the application of different tonnages and different types of equipment to a home. I mean, it's just like anything, you know, the iPhone 12 is better than the iPhone 2. And I think that it's just a learning process over time.
I found the
Especially-
poll if you want me to pop it up.
I
can hold.
can real quick. I think we're good with the poll. We got, oh, there we go. All right, never mind. Let's hit it. How efficient do we think heat pumps are?
Did you already give the answer while I was looking for it?
Yeah, I think this test is,
Okay.
well, ooh, okay, we're getting very varying levels of answers.
Okay.
Let's get one more.
I think that's all you're going to get.
All right, we're 50. We're halfway there. So one person said, or one attendee said, 100% efficient. So 100% sounds fantastic, and it is, but 100% efficient is the same efficiency as that toaster, because all the heat from that electricity is going to that toaster and it's being released into the room. So we'd call that 100% efficient. With gas furnaces, it's really like 80% efficient and then 90 plus percent, but it never gets to 100 because you always have that, you always have to have the exhaust for the combustion. So the person who answered 250 is correct. So when you're moving that energy with a compressor and it's properly sized and maintained, you can get 250% efficient. So, you know, everyone can take, a lot of folks like to take that to their bill and say, oh, well, I can save this much, I can save that much. You know, a lot of these percentages and efficiencies are done in controlled environments and things like that. But to the street, you're gaining efficiency. It's a proven technology. Heat pumps are everywhere. You know, like I said, car air conditioners. I think Mercedes was the first one to do the car air conditioner way back in the day. Everyone has a heat pump in their refrigerator. The refrigerator is just removing heat from the inside of the box and taking it out. Come home with your groceries, you put a bunch of burgers for a barbecue in the refrigerator. The refrigerator is removing heat from the hamburger with refrigeration and evacuating it. And then our moderate climate in the Northwest, we've got a big body of water out there that keeps the temperature relatively, without some extremes, relatively consistent. I think 80, 85, 90% of our heating days are between 40 and 45 degrees. So that's good to know for kind of hedging your bets. A lot of times we like to prep for the 100-year storm and things like that, which is good. You want to be prepared, but you also don't want to, you know, over prepare and maybe risk comfort. So, and it's a low carbon energy solution. So I'll touch more on that when I get to the rebates for Tacoma Power. A lot of houses traditionally just have this outdoor unit right here, which would be considered a central heat pump, unitary heat pump, traditional heat pump. This connects with refrigerant lines going up. This line set into the house, connecting to a coil or an air handler. And you have your power meter right above it. And then you have Macreo's trucks outside, one of our installs. But there's a lot of different types now. There's different zonal solutions for ductless, ducted ductless, multiple air handlers, things like that. So there's a lot of different kind of choices out there. So when we compare cost to heat, this is a modeled home. Bruce Carter, shout out Bruce Carter. He used to work at Tacoma Power. I think this was a chart that he made. There's some assumptions in here. I think there's assumptions with some of the prices of fuel, from back maybe 4 years ago. And also this, I believe this is an 1,800 square foot average home in Tacoma with 3 bedrooms and things like that, to put these prices into reference with varying levels of insulation, But as you can see, the Energy Star heat pump or the 9.0 HSPF heat pump and ductless heat pumps are the most efficient way to heat. And there's 2 reasons for that. Again, we're moving energy, but also we have very low cost power in this region because of all of our renewable hydro. So we're heating our houses with gravity from water to electricity, and then we're heating our houses with the sun, solar, because the sun is heating the air, and we can take the energy from the air, compress it, get it inside. There's the feel good part of heat pumps. Natural gas, 92% efficient furnace. I don't want to slam natural gas. That's a lot of the 2-stage great natural gas furnaces out there are 95, 96% efficient now. So they're just getting higher and higher. Just to touch on electric zonal and electric furnaces, they make great heat. There's no combustion with them because they're just an element, but they do use a significant amount of energy to do it. And then pellet stoves pump a lot of heat, like a campfire, right? So this is kind of a visual just on to get the ball rolling on efficiency and return on investment and energy bills and things like that. So how do we get energy out of the outdoor air? There's air source heat pumps, ground source, and water source. So in this area, this is just good. It's good customer service to let folks know of what's all out there, right? But ground source and water source heat pumps around here for residential, especially retrofit residential, are not cost effective. They're not cost effective because you're gonna have to do a lot of digging, and there's a lot of labor, and there's a lot of materials, and it's not cost effective because, again, we don't have extreme temperatures to the point where it warrants that type of system. Think like South Dakota or crazy cold places, things like that, or some industrial or commercial places around here have ground source and water source. But we're talking all air source because our temperatures really don't get below maybe 15 degrees, maybe once in a year, if that. We're mostly around the 40-degree mark. So central heat pumps. So similar to the one behind me, this is a visual of that. So just looking at this system right here, you have a outdoor heat pump, and it's connecting to the indoor furnace or air handler, depending on the fuel. And then we have some duct work running around. We have supply plenums, we have return plenums, then we have some trunk lines, as we can see. So central heat pumps, the analogy I like to say is the central system, furnace, electric furnace, central heat pump. That's your heart. And then your duct work are your veins and arteries. And so the most important thing about looking at a central heat pump is your veins and arteries, how fast the blood or the air can move through the veins and arteries, and then also how much pressure it puts on the ductwork. We have different ways of calculating that. I like to do it 2 ways. Visual, you kind of measure the ductwork. You can take airflow readings, but then you can also take static pressure, which is like the blood pressure of the system. So central heat pumps are fantastic. Just got to size them correctly, and there has to be adequate ductwork. And as you can imagine, they can be best for homes with existing ductwork. It's a whole home solution, and it helps for filtering air if you have a whole home solution. So there's the old Honeywell, static air cleaners. There's varying levels of cleaning air, different ways to do it. We have this smoke climate that popped up on us the last maybe 3-4 years, which is kind of strange. But again, you can kind of filter the whole air. So if you walk around your house and you have a central system, you're probably going to see one big register or one big return air, usually in a hallway, and it's usually next to a thermostat. That's the pressure release. That's your negative pressure. Your floor registers or your ceiling registers, the ones that are usually around windows, 1 to 2 in each room, maybe a small one in a bathroom and things like that. Those are positive pressure. Those are shooting warm air or cool air. If you have AC, they're shooting it out. And so one thing to keep in mind is if you have a heat pump, or you're looking to get a heat pump, or maybe some folks say their heat pump's not operating correctly, is the ductwork. So homes in Western Washington and the vintage of homes in Tacoma Power service territory and Puget Sound and Peninsula Light, all the utilities around here, they're built to heat. They're not built to cool. We didn't build houses in 1960 and 70 and 80 with the intention of having to cool our houses in 100 to 105 degree weather. So that's good for expectation, right? If your house was not designed for cooling and we're adding cooling to it, we have to do it correctly, and you have to set the expectation in the right spot. We're not Nevada, we're not Sacramento, where all the ductwork is enormous and the house was built with cooling. Little things like that are good to know. All right. Leaky ductwork is also an issue sometimes if the ductwork is in the crawl space. I'll go into some crawl spaces and on an appointment, and we're looking at everything in the home, and it can take time for an appointment. It's not just come in and here's a price, because you want to take all your measurements correctly so you have a happy customer and a long-lasting system. Sometimes between ductwork and the crawl spaces, that the pipes are off a little bit, so they're losing an inch of airflow into their crawl, and then that warms the crawl space, which isn't what you want to do. Sometimes ducts can just become disconnected. Some flex ducts, in new construction can get loose, or maybe a plumber was down there and did some work and bumped them. Those are all things that we look for that really affect efficiency and comfort, and indoor air quality for that matter. So that's central. Let's talk about ductless. So what's that unit on the wall, that box on the wall? What does that do? That's right here usually. Let's tell me about those boxes on the wall. So these are zonal solutions for very, very efficient heating and cooling. So when I say zonal, it's meant for a volume of air or a space in the home. Central systems have ductwork that kind of spider webs all around the house. And if it's good ductwork and it's designed correctly, it should evenly heat the entire house. Ductless heat pumps are zonal. So if you have baseboards and wall heaters in your home, your cost-effective option is a ductless heat pump system of some kind. There's different indoor heads for ductless units. What we're looking at here is a standard wall mount, which are most cost-effective. I think my personal opinion is the best way to move air, as long as aesthetically it's okay to have a unit on the wall. But sometimes there's restrictions. Sometimes there's not an interior wall we can work with. Sometimes there's a lot of windows in a home. And things like that. So there's floor mount units, there's concealed ductless, there's ducted ductless, and things like that we can work with attic spaces and different things. So ductless really is in the eye of the beholder for what a customer would want it to look like in their home. But also you can't just put a unit on a wall. Sometimes folks are like, oh, let me put it in the hallway, that way it's out of sight. Well, if it's in a hallway, it's going to not have the ability to move the correct amount of air, because hallways are usually pinches, right? On a big wide river, you have smooth and you can move a lot of water. It's not rapid, but if you pinch it, like in a hallway, or if you dam it by closing a door, you can't move air correctly. So those are just some things as you look at your house and kick tires to know. So the thermostat for these units is in the unit. So they come with remotes. The remotes change the temperature, change the mode for heating and cooling and fan only. And then they also can change the fan operation, low, medium, high, auto, and all that. So they can move air in different ways. But the temperature sensing part of the unit is in the head. And that's why having them in a large, wide open area where they can move air the farthest is the best. So they're best for controlling zones, smaller homes, and additions. So controlling zones, if you have inadequate ductwork, so this is something that I'm learning, out in the field, a lot of homes have inadequate ductwork, and sometimes the cost of adjusting that ductwork isn't the same cost as adding a multiple head ductless system. And the benefit of a multiple head ductless system is now you have basically pound for pound the most efficient way to heat and cool compared to anything, unless you're burning free wood in your fireplace. And you also control different zones. So some folks like to sleep with a cooler bedroom. So maybe they like their bedroom 64, but they want their living room 72. And then they have a kid who wants their room 70. That's how you can use these systems to increase comfort, and then sometimes cost. It's a little bit better. Smaller homes, tiny homes. These are the solutions for tiny homes. So think on that note. The size of the unit, size of the wall mount head depends on the amount of air in that room, or the volume of air that it's trying to control, and the throw of the air. If it's going to throw air in 10 feet into a wall, it's going to splash. If it can throw air down a hallway like 35 feet, that's ideal, things like that. And then if you're going to do an addition in your house, do not just find a piece of ductwork in your crawl space and take one duct and try and add 4 ducts off of it or anything like that, because then you're going to depressurize your ductwork and kind of mess up comfort. These are fantastic for additions. So things like that. So combination of mini split systems. We have an outdoor unit here. So there's always an outdoor unit, and then there's different types of indoor units. So there's ceiling cassettes, ducted, ductless, floor mount, wall mount. I'm a fan of wall mount as long as there's space on the wall and the customer is okay with it being on the wall, because they work the best. They can move air the best. The floor mounts are great for windows, or if they want it low. Floor mounts are great for converted attics where there's no ductwork, or maybe they didn't correctly size the ductwork to get to an attic bedroom if it was converted. And then ducted, ductless are great for really broken floor plans where there's adequate attic access to get that up there, because then you can kind of take a ducted, ductless and turn it into a mini central system, which is out there. So some things on here: increased flexibility. So the units are very flexible now. And I like to tell customers at their house, not only like what's going to look like, but what's the install going to be like. Every unit needs to be connected to the outdoor unit with 2 refrigerant lines. For the ductless units, the refrigerant lines are about the width of your index finger and middle finger, slightly different, but there's refrigerant lines that connect to them. There's a power cable from the outdoor unit, and we try and hide all that in things like line hide, which would be this 4-inch white gutter material. It protects the equipment. Looks cleaner on the house, looks like a gutter, but those are going to run in an attic or a crawl space, or on the side of a house if need be. So that with ductless, there's always going to be things outside. There's outdoor unit, and then we've got to connect the units. And it's just good when you start to visualize the system, not only the wall mount units, but how it's going to connect. And each indoor unit has to have a means to get the refrigerant, the condensation when it's in cooling mode to a safe spot. And that's connecting to a gutter, dripping in a flower bed. It's just water, getting it to a spot where it's not on a walkway, it can't just drip in the crawl space and things like that. So that's something we do, but it's just good to know. They're great whole home solutions. Sometimes folks ask, what would you do in your house? I really like ductless heat pumps. I just think they're cool. They're the way the rest of the world heats and cools. Central America, Europe, Asia, things like that. One thing to consider though, one in every room, hyper comfort, hyper control. As you add units, the cost of the system goes up because the outdoor unit needs to get bigger. There's more ports for indoor units. The indoor equipment, and materials and labor all has cost too. But that's stuff we can work with on as you kind of investigate different solutions. So I'm going to touch on this. You can Google heat HSPF and SEER nowadays and probably get it faster than how I can explain it. But if we were just to do a flyby of how these systems are rated, the good thing is there's federal standards. The Department of Energy has minimum efficiency standards for manufacturers. So that way, we're not just sucking energy left and right with natural gas and power to heat our homes. So there's minimum efficiency standards. 8.2 HSPF is a number that's important for Tacoma Power and heating equipment in this area. A lot of folks, throw SEER around, seasonal energy efficiency ratio. SEER is more of a cooling metric for the efficiency of equipment. So if you're adding AC only, you'll hear SEER. So if you have a gas furnace and you want to just add an air conditioner, let's say you bought a brand new great gas furnace like a year ago, and you want to add AC now because it's getting so hot, you'd most likely add an air conditioner and the air conditioner would be sized to your ductwork in your home. But you'd hear SEER. When you hear about heat pumps, ductless or central, like the one behind me, you're going to hear HSPF, heating season performance factor. The minimum that you can sell that's on the market is 8.2, and Tacoma Power has a benchmark of 9.0. So the rebates from Tacoma Power are meant to help customers increase the efficiency and it's meant to cover that incremental cost of going to a 9.0. Some other benefits to the rebate and just the process is when you do a rebate with Tacoma Power and other utilities, you have to do a commissioning and sizing document. You have to size the system correctly and you have to balance it to the home. And that prevents oversizing and undersizing, which is something that happens historically, but the rebates are meant to incentivize the more efficient equipment, but also make sure that more efficient equipment is sized correctly to heat and cool the home. And each home is different, as we know. So what to expect with a heat pump? Click through all these bullets. So continuous heating at a lower output temperature. So oil heat is really hot. We're burning oil and it's coming out. And sometimes you see the old houses. My friend bought a house with oil heat and there's like soot marks around the supply in the wall where the air's coming out. It's like, ugh. And you get used to it. You're used to your heating system. You know, we adapt really quick to our home and temperatures and things like that. Humans adapt. But, you know, I would go up there and I'm coming from my house or outside. I can smell it smells like oil heat in here and you can smell it. And but if you're in there all the time, you may not get used to it. You get used to your environment and you get used to that type of heating system. The reason why I'm hyping this is expectation is everything when you're getting something new, whether it's a new car, new pair of running shoes, or a heating system. You got to know what you're getting and how it's going to operate and how it's going to be different from your old system or what you're used to. Because no one likes surprises, and it's good to educate folks on what they're getting or what they're thinking about getting too. So oil heat, natural gas heat, really hot, electric heat, like a electric space heater, electric wall heater, baseboard furnace. It's a little bit cooler, 110 degrees maybe at the register, but it's still hot to us because we're 98.6. Heat pumps are getting way better at getting more heat into the air at the supply point, and that would be below a ductless unit, or with a central unit like this, it'd be at the register. But it's going to be more like 95, 100 degree air. No one wants their house 95 degrees, but if we're 98.6 and we feel 95 degrees going over us and we had an oil furnace and we were used to 130, what's the expectation? If someone didn't tell you it's going to happen, you might think that your system's not working correctly. It's not the case. Heat pumps are highway mileage devices, long sustained runs to give the house energy or give the house BTUs from the outdoor air and maintain a temperature. So sometimes folks like to turn their heating system down to 10 degrees at night, and then in the morning they turn it up. You can do that with gas furnaces. You can do that with oil furnaces, propane, things like that, because they produce so much heat at any given moment with their combustion. Heat pumps, you want to really just set it and forget it. A couple of degrees down at night for a central system. For ductless, you can do whatever you want with each room, but the same thing goes for ductless. Don't turn them down a lot. Don't turn them off. And the reason why you don't want to turn a system down a lot, like with a heat pump, is if you turn a system down, say 5-10 degrees at night, and it's cooler at night, we feel the air, right? We feel the air in the room. The air in the room's colder. It's 64 and I'm waking up, have my coffee. I want to have it 72. You can change the temperature of the air with a heat pump, but the surfaces in the room, the hardwood floor, the coffee table, the countertops, the walls, everything has lost its energy, and you have to add the energy back to it because your house acts like a battery to an extent. And when you change the temperature a lot, the system has to work harder to achieve a temperature. So it's just good that these little things are good as you walk around. And maybe, yes, for some folks that have traditional heat pumps, it might be helpful just to hear it again. It's okay if your heat pumps run a lot outside. It's good to have a heat pump do long sustained runs when they turn on and off a lot. That could be some control issues with the settings, and it could also be oversizing, short cycling is what we call it. And that's not necessarily the best thing to do. Clean the filter. It's very, very important. That gets to comfort, indoor air quality, longevity of the system, getting your miles out of your system. Got to clean the filter. So improvements. So with systems, with heating, and most heating systems, I'd say the lion's share of the heating systems out there, it's single stage equipment. I have a single speed gas furnace in my house. Your traditional heat pumps, single stage. Thermostat calls for heat, system comes on, runs for a while, thermostat gets happy, shuts off. 0%, 100% operation. That's the way that most systems work. Now you get to two-stage equipment. So two-stage gas furnaces are fantastic. One, the incremental cost of a single stage to a two-stage isn't a lot, but you get a lot of comfort out of it. So a system can run at 60% for as long as it needs to. You can change those, and then it can come on at 100%. So kind of back to that 100-year storm thing. If you have a two-stage gas furnace or a two-stage heat pump, the first stage is going to come on, do a long run. And if it's 45 degrees out and you want your house 68, you don't need to put as much heat into the house as you would if it's 30 degrees outside and you want your house 68. And that's where the stage ability comes in. The best way to heat and cool in regards to function and operation and controls and communication are modulating gas furnaces and or variable speed heat pumps. Variable speed heat pumps are the best way to heat and cool because they can adapt the system to what does the house need for heating, what does the house need for BTUs at a given temperature, and how hard does the outdoor unit need to work. So just think about our winter. If it's 55 degrees out and you like your house 70, you don't need your system to come on at 100%. It can run at 20, 30% and do long sustained runs to maintain. And when you maintain temperature, you're constantly giving the house BTUs that it's losing. And then as the outdoor temperature gets colder, the system knows that it has to work a little bit harder. Maybe it runs at 60% capacity. And then when it's really cold, it has 100% capacity to heat the house. When I say really cold, 25 degrees, that's really about as cold as it gets. And then when you do that, when your system's adapting, it's just running kind of like slow, giving the house energy. Some folks are like, oh, but it's using a lot of energy because it's never turning on. But if it's using 500 or 600 watts of energy, as opposed to 0%, 15,000 watts, 0%, 15,000 watts, you get a lot of efficiency out of it. So I like to run. My analogy is Eliud Kipchoge is the best marathon runner in history ever. Maybe the best runner in, history of the earth. When he runs a marathon, he does not sprint 100 meters, stop, sprint 100 meters, stop. He paces himself over the course with some preparation. So he paces himself. Variable speed systems pace themselves to what your house needs in the outdoor temperature, as opposed to that start, stop, start, stop. So for all your runners out there. So maintenance is critical for heat pumps because you need it as clean as possible to get the surface area and the contact with the air to remove or add energy. Ductless heat pumps right here, the gal or the lady in the top is removing those reusable filters. So those collect debris to keep the heat exchanger clean. And you can just, they're reusable and things like that. The outdoor unit, there's maintenance there, right? Cottonwood gets on them, gets sticky, leaves, you see them neglected, but they're not maintained properly. There's weeds growing in them, things like that. That affects airflow, and airflow affects efficiency and comfort and longevity of the system, and also preventative maintenance. If you don't clean them, things can break. And then if you just made this great investment in a high efficiency piece of equipment that you want to last for 15, 20 years, it's hard to make it do that if it's not maintained properly. The filter on, we're looking at a ductless filter for central systems. You have most folks have a 1-inch filter. 1-inch filters are great. They're great for keeping big debris off of the system, but they're not getting the small stuff. If you have a really restrictive filter, like, the MERV, the HEPA and whatnot, and they're not like an air cleaner, sometimes folks like to double up, triple up filters. I've seen crazy stuff. The mindset's there, like wear 1 mask or 2 masks. More is better. A lot's fantastic. Not for airflow. And if you're restricting airflow over a heat pump, it can't release the energy, and it can short cycle, it can freeze up, it can do goofy things. It's not a good thing to do. So there's products like air cleaners, the Honeywell air cleaner that has the old school that had static on it. There's American Standard has an AccuClean that can remove smoke, small debris. And it's doing that by having things stick to it. So it's not like a restrictive filter. It has a way of having the small stuff that can get through a standard filter stick to it. So that's good to keep your system clean, because a clean system is just going to run longer. And then it's also good for us, right? Less stuff in the air that we don't want to breathe, the better, because we need food, water, and oxygen, or clean air. So when you shop for a heat pump, there's a lot of different brands, there's a lot of different companies, and there's a lot of different technologies, as you guys have kind of been hopefully brought up to speed on a little bit. The biggest thing is, there's a lot of good equipment out there. The equipment, I would say, the most important part of a box or the equipment you buy is the company that stands behind it, and the sizing and the application to the home. Every home is different. Every occupant of a home is different. And if you don't set the right expectation of a system, or the installation of a system, or how a system is going to look, people can make assumptions, and we don't want that. We want to be as transparent as possible. So Mercurio's is a Daikin American Standard dealer. But there's Mitsubishi, Trane, and American Standard, are kind of apples to apples. Carrier, I think William Carrier invented air conditioning. My friend's parents, who used to own a HVAC industry, named their dog Willie after William Carrier. But I think in this, as you guys get multiple estimates around here, at least for ductless, the market share is Daikin and Mitsubishi. Mitsubishi makes great products as well. But what's the warranty? What's the company that's going to stand behind the coverage, and things like that? Installation and application, proper sizing. Those are some things to consider. And proper sizing for a home takes time with a call, because you don't want to miss anything, because that can rear its head back. So what size is right for these equipments? So sizing. So Tacoma Power does a PTCS performance tested comfort system kind of certification for a system, and there's a lot that contractors have to do to meet that, but it's good because it's a third party just making sure that these systems are sized correctly. And you hear about balance point. These are things that we do as contractors, and that the utility and Bonneville Power Administration, our regional body for the area, they kind of oversee this as well. And there's a lot of eyes on it, because you want happy customers, and utilities are making an investment in this piece of equipment if they put a rebate on it, because they want this investment to be longevity, happy customers, and efficiency over time, because they're making this investment because they want their grid more efficient, and the grid wants to be efficient for a utility so that the region can be efficient, and then we can use our power correctly. So sizing is everything for heat pumps. Sizing and what's the expectation to the customer. And sizing has to do with what does the home need and what can the ductwork handle, and then where can ductless heat pumps go in a home. So let's see who did this. Knowledge TPU programs. So someone put note in the chat here. Oh, Janda did. We have contractors. We're a Tacoma Power participating contractor. There's other contractors on that list, but we do this for the customer. I try and communicate it best to the customer, what we're doing and why we're doing it. To give my friends at Tacoma Power a shout, I told them I would let them know, every customer know what a rebate's about, because sometimes folks don't know how it's applied, but it's important. So installation, here's some examples of ductless heat pumps on the wall. Some things to think about. You want the unit. I would want the unit where it's going to perform the best. Some folks want the unit where they're not going to see it. And maybe we kind of go back and forth a little bit. With ductless, they're great for the main living area because the main living area is a large volume of air. They're great for bedrooms where I need this bedroom cool. Warm air is a little bit more active than cold air. Heat seeks cold with thermodynamics and things. So hot seeks cold. Cold air does not seek heat. Cold air goes and sits. It's denser. It just is lazier. Feels great when it's hot out. It's lazier. You can't get cold air to go down a hallway, turn right, and go through a door from a ductless. For central systems that have ductwork, inadequate ductwork on the second floor, and for ductless that aren't on the second floor of a home, things like Old Craftsman, South Cushman, Division, things like that have these second or third story bedrooms, cold air is not going to go up 2 flights of stairs and keep your bedroom 68 degrees. It's just not. Again, that gets back to how our houses are designed for heating, not cooling. So in those situations, a ductless system in that area will condition that area. Third floor, attic, converted to a master, no ductwork. The only solution to be comfortable and satisfied over time is a ductless system heating and cooling that zone. Location is everything with the ductless. So outdoor systems and some things to look for. We kind of talk about, cottonwood, weeds, things like that. Dogs like to mark them at times. But you're going to have a unit on the side of your house when you add a heat pump. There's going to be electrical to it. It's a 240 circuit. We look at your panel. We have electricians at Mercurio's on staff that do all that work. You're going to have line set connecting. We use line hide to the best of our ability. We try and keep them vertical. We try and use attics and crawl spaces kind of as a highway to get things where we need to get them to keep things off the side of the house. This image on our left here, you can see that they did a wall blow for insulation where they drill a hole high and low and pump that thing with cellulose to add more efficiency to the home, which keeps more heat in, which can change the size of heat pump that you need or furnace or anything like that. More insulation better, and it holds heat in better and keeps hot energy out in the summer. The bottom unit there, that's a wall mount system, or excuse me, a bracket mounted outdoor unit. Those are great for where there's a lot of snow. There's snow in that picture. We don't really have to worry about snow around here all the time. That's why we put them on a little bit of risers, 3, 4, 5 inches. If we do get snow like last winter, it goes away quick, sadly. But Montana, places where there's snow drifts, they can mount them on the wall to get them up higher so they're out of the snow for airflow. Wall mounts are good for those situations. Sometimes they may not be the best for comfort, or if a customer would like them bracketed on the wall like that, the expectation is, okay, they're very, very quiet, like 44 decibels, 50 decibels, but they are a piece of equipment that does have moving parts. Moving parts make vibrations, and if it's connected to a stud and your perfectly silent house before now has a slight vibration, those are little things that can creep up that are good to set for the expectation. So we talked a lot about heating and cooling and your refrigerator, but there's other types of heat pumps out there. So on the left here, we got a kind of like transparent shot of a heat pump dryer. So the same way a heat pump removes heat and pumps it into a space, your traditional dryers are electric. They just have a big electric element and a blower motor. It's like a big space heater in a box with a fan. Sometimes there's gas dryers out there. Heat pump dryers, again, they're heating up the place where the clothes are that's spinning, I guess the drum. But they're doing it just not as hot, so they take a little bit more time. It takes more time, but it's significantly more efficient. They're and you can't do like large terry cloth loads because there's so much moisture, it would take forever. Again, you're making an investment in efficiency. You're getting efficiency. You're going to help your bills. It's better for the environment, but you're going to have to just know what you're getting, longer cycle times and things like that, but they work great. On the right side, there's a traditional electric water heater on the left side of the image. And then on the right side, you see a heat pump water heater. So again, you're heating the water and maintaining the temperature with a heat pump, and you can just gain efficiency. Heat pump water heaters, are a little bit more easy to predict your savings because they're not really contingent on the outdoor air temperature and the indoor temperature. You kind of just, and you use water, hot water specifically, it's more consistent over time in a home. You don't take more showers in the summer than you do in the winter. Hopefully you kind of take showers all the time consistently over the home and things like that, cooking, and things like so heat pump water heaters are fantastic for that application, but heat pump water heaters got to go in the right place. Garages, things like that are great. So Tacoma Power programs. So Tacoma Power offers rebates, which is an after-tax credit that you get to help with that incremental cost of adding a heat pump to a home. And then they also have 0% 7-year loan options available. So it's either -500 or 1,000 or 10,000 and 4,000 for a 0% 7-year loan, where they put a lien on the property as a secure loan for the city. It really comes down to what the customer wants, and then to get to those different categories. It's good to have a contractor out, and they can tell you what you can get $500 for, what you can get 1,000. Central heat pumps, if it's 9.0 or greater, you get 1,000. The $10,000 and $4,000 loans are only for electrically heated homes, not for say an oil customer who's looking to add a whole home ductless solution or a central system and things like that. So we got a comment in the chat real quick. Janet put the link to the pages, and you can call Tacoma Power, and the folks there are more than willing to help. 253-502-8363. So biggest thing with the rebates are work with a participating contractor, and Mercurio's is a participating contractor. There's the plug, but participating contractors for everything. And when you talk about heating systems, you get so focused on the heating and cooling aspect, but Tacoma Power also has great opportunities to save for insulation and windows and controls and things like that. So don't neglect the envelope of the home, because the attic insulation, the floor insulation, the air sealing, the windows, the type of windows, the shading, they have a shade tree program that they ran for a while. All that has a huge ripple effect when it comes to sizing a heat pump system or cooling system. And then it also has a huge effect on comfort and how that system works in the home. So don't forget that stuff. So there's brochures. There's info on their website. We try and do a good job of handling all the paperwork. So if you were to, participate in a program with us, we do all the balance point. All that stuff is done by the contractor. We give you the rebate instantly as a credit if you'd like on the estimate and the invoice. And then we just have you fill out the application. One thing to expect with a rebate from Tacoma Power, a project, whether it's into windows, insulation, or heating or water heating. I didn't give a shout to the $500 instant rebate on heat pump water heaters as well. That's through contractors, and that's through retail as well. So Lowe's and Home Depot participate, and they have a loan option for that as well. But there's going to be multiple inspections. We pull electrical, mechanical permits on all of our jobs, so there's oversight there. And then the folks at Tacoma Power like to do customer outreach and see how we did as a contractor and see how the system's doing by doing some different types of inspections. So there's going to be multiple inspections for the heat pump system. So I work in Mercurio's. Mercurio's is a longtime partner with Tacoma Power. We've done a ton of installs. We focus mainly on residential retrofit applications. So we can get good at that. That's kind of our bread and butter, not commercial or new construction. And we have good installers. We have install managers, good owner. We have comfort consultants that can come out and just give you a price and, you know, kind of tell you how things work. And if you have any questions, you can give me a call. My cell's on there and our office is on there. And yeah, let us know. So it looks like Jane's putting that on there, and I'm gonna tap ahead to questions. If there's any.
I haven't seen any questions pop up yet, and the person that wanted to know about the lifespan had to drop off, I think, so we may need to follow up there.
Cool.
I did put in the link on how to find the recorded version of this, which will be up in probably, depends on when they can get to it in our media department, but it may be a week or two, might be a couple days. But you can find that on the city's YouTube channel, or you can find it on the EnviroHouse website. And I'm going to put that link in, which is also where you can sign up for workshops, remembering that the next one up is pruning on the 23rd. That will be with John Wakawiak, who also happens to work at Tacoma Power. And then I will add my information. So if any of you have questions, you can follow up with Jordan directly or with me, and I can share that with Jordan or with Tacoma Power. And I'm told copy the chat, but I don't know for sure. So
I'll give one more thing for kind of questions or one last comment. So we talked about Tacoma Power's rebates, $500, $100, or excuse me, $500 and $1,000 in their loans. But most utilities in the region, almost all of them that are local, especially like your Parklands, your Peninsula Light, your Peterson Energy, they're all going to have different rebate amounts to incentivize more efficient equipment, whether it's gas, water, or gas furnaces to go to a high efficiency gas furnace. But there's different tiers and there's different amounts. So if you guys are talking to anyone or you have friends that don't live in Tacoma Power territory, their utility most likely has a rebate available. So always ask for those because it puts money in your pocket, and it also lets the utility get energy savings. They can do some better power planning and keep the grid more efficient for the area.
okay. Well, if there are no other questions, I'm going to end the webinar then, which will stop the recording. And Jordan, if you have anything you want to follow up on, give me a call and we will go from there.
Sounds good, John. Thank you. Thank you, David, for being here. Thank you, everyone else. Thank you, Jan.
Okay. Bye.
All right, bye-bye.